So this is the Venus series machine seminar. We're going to talk a little bit about the Zhafir. The Venus machines, it has the same control as the Zhafir, except for the Zhafir has three different objects that are hydraulic. They have hydraulic ejectors, hydraulic cores, and hydraulic cylinders for the carriage. That's basically the only difference between the Zhafir ZERES and the Zhafir Venus series machines. Other than that, everything else is electric on both machines. Of course, the Venus machine is fully electric, and the Zhafir ZERES machine is hydraulic slash electric. We begin with the safety, because safety is always the first thing I always like to talk about. We don't want anybody getting hurt on these machines, and we'll do this quickly because this is the third time I go over the safeties of that we send out. We send this out with all the injection molding machines, just as a reminder of the safeties that are supposed to be adhered to. The first section is the operator safety checklist. And this comes with every machine. So if you have a machine already, you should have this inside your packet. Then we have the checklist for the operators. Then we go with the setup person's responsibilities. And we have a checklist for the setup person. And it's always good to have hanging around. Then we go over the maintenance personnel responsibilities, and we have a checklist for that also. And we go over different other procedures and responsibilities, PPE, stored energy, employer responsibility, employee responsibility, good housekeeping, protective gear, inspection, grounding. Again, grounding on these electric machines is extremely important. You should have a grounding rod at the machine and ground the machine properly. That's only because the servo system on the machine, the drive, actually looks for a zero reference, and it uses that earth ground as a zero reference. So if you had a conductor, grounding conductor with the other three, line 1, line 2, line 3, going through the bus system, that tends to pick up noise and harmonics. Then your zero voltage is no longer zero voltage. It's a deviation of anywhere from 2 volts to 30 volts. Potential injuries that can occur on the molding machines. So you, again, have to take care when operating these machines. Guarding. If there's any guarding that needs to be removed off of a machine, as per the sales agreement, you should request permission from Absolute to remove any guarding on the machines. Otherwise, we'd have to write you up a safety letter, and it goes to the owner of the company stating there's a safety violation, and it voids your warranty, and we are no longer allowed to service the machine until all the safeties and guarding are repaired. Again, the machines are certified by CFR 1910, NFPA 79, ANSI B 151.1, which me and Michael Ortolano are a member of. We actually sit on that board. ANSI B 11.19, NEC, and the ANSI SPI B 151.27. We'll go over this tomorrow, but today what we're going to do is cover the actual machine screens. So if you guys would ever want to find out where you could find all these simulators, etc., just go to support. Sorry. support.absolutehaitian.com. And what you do is you sign up for this portal. It's a portal that has a lot of information, simulators, troubleshooting guides, a lot of different things that a lot of customers ask for. So by logging in, you're then able to gain access to all of the information that's available on this site. Again, it's support.absolutehaitian.com, and all you have to do is register. I do the approval, so I will approve it, and off you go from there. Again, if you want to look at anything for the setup mold protection that's on the Venus series, let's look for the simulators for the ZERES. So we have a ZE simulator. You just have to click on it, and it'll download. Once it's downloaded, you can open it. And basically just run it just like do a slideshow, and you can then just push the buttons at the bottom and it'll step through all the screens. So the first screen we have is the hour meter screen. You can reset the power on, motor on, full auto, but only with a higher level now, I believe. I don't think you can do it in lower levels. Maintain screen. If you have this screen and it all X'd out as this right here, it really doesn't do you any good. You should always have these checked off. These should be a check mark on these screens. And what it does is when there's a problem with the lubrication or the timer times out, it'll then show an X, and it'll come out with a message on the screen that, for example, injection belt maintenance required. Then you just have to look at this right here, injection belt, look at number A, and you just have to check the tensioning on the belt. It's as simple as that. Prepare, this is your mold adjust settings. It's a little different on the new ZERES 2. You do not have this box anymore, but it's similar. This section up here is when the mold, when your machine is in setup mode. So putting the machine in setup mode, it'll then go off of these velocities that are set in this mold adjust setting. This is your actual clamp force that you want to maintain. And this is your injection speed in millimeters per second when it's in setup also. This button here, if you turn that off, then you're able to dry cycle your machine. You can run the machine without the injection unit activated. This section right here tells you what core selection is going to operate with a robot. If you use a photo sensor, then we have a photo sensor timer. And we have a cycle safety time, which is your overall cycles timer. And cycle interval timer is the amount of time in between cycles. Down here, you have the safety timer for your auto die height. You have a mold measurement area. Then you can move to mold height. Pushing that will move it to the mold height number that you place in this box right here. And then you hit the auto, put it in setup, hit auto mold adjust, and it'll automatically set your die height. The new ZE machines and VE machines now have an absolute encoder on the die height. So it's a lot faster than the older machines. So what happens now is the mold goes to close, it'll back up, then it'll touch off the face of both halves of the mold, then it'll open, adjust the close once, open, and it's complete. So it's a lot faster now than it was in the past, where it would take 4 or 5 shots before it would actually do the die height. Now it's just one simple shot. Quick set, that's your entire process on one sheet. Again, I tell customers that it's a good sheet to use if you want to actually have a cycle sheet for your process. You can just print this one sheet and you're good to go. So everything on the screens that I'm going to discuss is on this sheet right here, except for the optional stuff, obviously. All right. We'll start off with heater functions. You have a heater temperature control. Hopper temperature control, that's for your hopper. Synchronous heating. If you turn synchronous heating on, the normal way of heating the barrel on these machines is the nozzle goes first, and it goes to front zone, center zone, rear zone. Some materials you want to heat at the same time, so you can then turn synchronous heating on. And what it'll do is actually heat, bring your temperatures up all barrels at the same time. You have a standby mode. The standby mode is if you want to lower the temperature for a certain amount of time, you can put it in standby. So you actually select time, put how much time you want the heats to go down. You also have an automatic standby function. So if you turn that on, after the time that you put in this box right here, then the heats will go down into standby mode. Standby mode is the mode that's you set in this area right here. So whatever temperature you put in there, the barrels will cool down to that temperature until the timer times out, and then it'll heat back up. So once this timer times out, the heats will turn back on, and it'll go up to temperature, to whatever temperature we'd like. What is that good for? Well, if you're running like a PVC machine and your operator goes to lunch for 30 minutes, you put 30 minutes in here, you turn your standby on. What happens, the heat will drop to a safe temperature. After 30 minutes expires, it'll heat back up to the temperature that it was when it was running. These are your parameters for your different zones. They have a KTT instead of PID. It's the same function. Down here you have your screw cold start protect, which is so you don't start your machine with the temperatures inside the barrel too cold. So you have a cold start prevent time. Auto tuning. This is a nice feature on the Venus machines. You don't have to have the barrels at room temperature. All you have to do is have them at least 40 degrees centigrade, lower than the actual value. That's around 100 degrees Fahrenheit. You don't even have to optimize all the barrels. Let's say you just change your nozzle band. You shut these off, turn these to off. Press the auto tune button, then turn the heats on, and it'll automatically just tune that one zone. This is your barrel temperature, your plus or minus deviation. So if the barrel temperature goes above or below the max minimum temperature deviation, then the alarm will go off. Somebody has their microphone on. Can you mute your microphone, please? Thank you. This is a scheduled startup. The funny thing about this one is you have to put a stop time in before you put a start time in. So let's say you want to start your heats up at Monday morning at 7 o'clock a.m. You select this, you turn this guy on. First, you have to put a time in here. Let's say you want to stop at midnight on Friday. So you put 24:00:00. Check this guy. Put your Monday time in, and keep your heats, keep your machine on, obviously. And then when the 7 o'clock comes around, the heats will turn on and everything will heat up. It's good if you have a lot of machines and you want to do a soft startup. Just start a couple machines every 10 or 15 minutes apart so you don't have a surge in power. That's a good feature to use for that. The client page. We now have on the new machines, we have a programmable core where you can actually do sequential cores. You don't have to use the standard program. With this function here, this is also available. Let's say you want to use core A. You select your position where you want the core to start pulling, or you can use time, position, whatever. You can have a standby mode. If you want it on the front or the rear half of the mold, that's that function there. You have a delay time, you have an actual time if you want to use time, and you have your flow and pressure down at the bottom. Now with the sequencer, you can actually choose what sequence you want the cores to react, pull and set. Again, core out is the same as core in. I think I did that backward, but that's okay. It's the same values. I don't know if I have the sequential core on here. Probably not. Yeah, the core program, this guy right here. So you'd have to turn that guy on, and then you'd have the sequential core program. Air blow, you get two air blows. One's on the stationary, one's on the moving. That's female and male. You can add up to 8 air blows on this machine. Compression injection or coining, you can choose between 4 different options in a combination of A1, A2, and A3 and A4. So actually you have 6 different combinations. Mold open, you have your position and your speed. So from 0 to 3 inches, it's going to operate at this speed. From 3 inches to 199 or millimeters, I'm sorry, it'll operate at that speed. And from 199 to 200 millimeters, it's going to open at that speed. Close is the same thing. This is your mold protection area right here. You'll see a couple grade boxes. So if you turn on the, there's the mold protection. 2-step mold protect down here. It'll actually allow you to enter values into those boxes. So you'll have another box here for more accurate mold protection. Ejectors, again, you have your ejector forward, your ejector velocity, and your ejector pressure. On this machine, because it does have hydraulic ejectors, you do have ejector pressure settings. So again, you have your different functions. You have your vibrate, your continuous, and your hold functions. Mono ejectors that you want to do for your knockouts. If you want to have a delay or you want to have a standby time. It does have eject on the fly. That's a standard option on all the electric machines. And you pick your start position. Your safety time is your time for your ejector timers. The other nice thing about this, well, first let me explain vibrate. Vibrate is actually tip stroking. So what happens is the ejectors will go all the way to the ejector forward. Then it'll go to the S1 position, then back to the SE position for the amount of times you put in a count here. So actually it'll go forward, back, 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 and then all the way back. With continuous, it goes all the way forward, all the way back, all the way forward, all the way back. With hold, that's used for when it's in semi-automatic. Hold is only, what happens is the mold will open, the ejectors will come forward. You have to open a door, take the part off the mold, close the door, ejectors will go back and they'll cycle again. Again, we have now an encoder for your mold adjustment. If you want to set a special semi-automatic time counter, you can have one of those put in, that's an option. Fast auto mold adjusts, again, that's because of the encoder. Dual stroke eject. So if you turn dual stroke eject on, that's a pretty good feature. What it does is you now have a duplicate of these boxes. So you can actually have 2 different ejector strokes. So you can have like ejector A go to 50 millimeters as over here, and it'll go back. So you'll have a single count. It'll have double of everything. So you'll have your counters. So let's say you wanted ejector A to have one count. So it'll go forward for a certain stroke, then it'll go back. And on the second stroke, it'll go whatever you put for your second ejector. So let's say you want it to go to 100 millimeters. So your second stroke would go all the way to 100 millimeters and come back. So what good is that? What I did at the show in Canada, I was running some little connectors with a star runner and a robot. So what I did was I had the robot come down, go in. I ejected just partially to remove just the star runner. It picked up the 4 runners with the robot. Robot went out of the way. Ejector went back. Then the second stroke, the ejector pushed the parts off. So you can use it for a lot of different things like that. You know, if you have a part that you want to just do it in 2 stages for your ejector, you now have the option of doing that. Same with double air blow. You can have a double air blow. Ejector auto adjust. If you turn that on and you tie your ejectors in, you'll come up with a button on the ejector page, and you just push the button and it'll automatically adjust your ejector back positions. Intermediate mold open. That's for a robot. For example, if you wanted your mold to open just halfway, have your robot come down and hold the part for instance, on a 3-plate mold where the core is the back of the rear plate. So you'd open up just enough for the robot to come down, hold the part, then you have the mold continue to open it to the full open position. Then the robot can then take the part away. Select which ejector to cooperate with the robot. Again, you could tell the robot to either go off the ejector A or ejector B. S-curve time, that's just part of your ramping. So is the mold close and mold open ramps. Clamp force sensor, if you had a clamp force sensor, that's an option. Again, electric door is also an option. Mold protection mode, you can have force release, or I believe there's another one in here. But just different modes for your mold protection. And you have an insert mold operation function. Okay. All right. Any questions on the ejector section or the heating? Okay. Inject. Start off with auto purge. So you can set up your auto purge settings right here. I usually use auto purge only for purging through a hot runner mold. I'll lower the pressures and speeds, not the pressures, but the speeds. And I'll make sure that when you purge through a hot runner mold, you don't blow all the tips open. So I usually use auto purge to just purge through the mold. This is your sprue brake or carriage backward function. Again, it's hydraulic, so you're going to have a hydraulic number. This is your carriage forward. So what you do on the carriage forward is you have to set a 0 position. So I normally close the mold, bring the injection unit forward, hold the button after it's all the way forward, then I'll hit the 0 set button to 0 the carriage out. You have your injection unit backward speeds and pressures. You also have a nozzle control. If you want to add a hydraulic or pneumatic nozzle shutoff, you can actually have the controller built in. You just have to buy the hardware. And again, you can have mold open during charge, clamp during charge, nozzle open for your delays, etc. This is your injection unit forward and back setup mode. Inject. Now there's a pressure here. That, again, this is in metric, so it's MPa megapascals. This pressure is actually a theoretical pressure that's calculated through a load cell. It's on the injection unit. So on the injection unit, they put a load cell, which is a scale. It's an analog signal, 0 to 10 volts. And the system takes that number and creates a theoretical pressure. Because it's an electric machine and there's no flow, there's no hydraulic flow, there's obviously no pressure, because pressure is resistance to flow. And if you don't have anything flowing, then there's no pressure value. It's actually a torque value. So that being said, the only flow in the machine and the only way to find the flow of the machine is actually measuring the plastic pressure and flow. But you cannot think this injection peak pressure is an actual injection pressure. It's a theoretical pressure. Again, you have your injection positions, your velocities, your hold, pressure and speed, pressure and time, I'm sorry, and speed. Your cutoff settings right here. I usually disable this guy right here, because what happens when that's turned on a lot of instances I've been addressing, the pressure will go up. When it hits your hold pressure, it'll go all the way down, then it'll bounce back up and do one of these little curves. So by turning this velocity off, it eliminates this guy right here. It's kind of like a delay in ramping. So if you guys ever see a chart that you have a problem with your injection and it's going down when it goes from boost to hold, make sure this VP velocity setting is turned off. You can turn it off in the back right here. Let's see where it is. This may be one of the newer ones, so it may not have it. No, I don't think it has it. But anyways, a lot of the newer machines have that function that you can just disable that. If you're not able to disable it, just put this at max, the max value. That'll eliminate this guy right here too. It's better to shut it off, because you don't have to worry about it if you don't see it, out of sight, out of mind. So this is your cooling time right here, and high precision molding, which I usually don't use either. That's what that does, is it tries to control the plastic flow of the material, and it's always best to not pressure limit your process. And again, this is an electric machine, so it's kind of difficult to really say, hey, this is your pressure limiting your injection pressure, because there really isn't any pressure in the injection. Again, next week, what we're going to cover, if anybody's interested, next week's seminar is going to be on processing. And this is your injection curve. So you set up your scale here so you have a nice view of the curve that you're looking for. You can have 10 overwrites. This will overwrite your curve 10 times. And you can tell it what you want to display, pressure, velocity, or both. And you can have a limited record or unlimited record. You can set your curve, etc. You can also save a curve. Once you have a nice curve going, you can actually save it to compare it to other curves. All right, my screen don't want to work. All right, charge. On electric machines, this guy should have both on. Should have before charge and after charge. So this should be turned on right here. You don't need a lot of pressure release, but you do need some. And what that does is when you inject your material, the front of the screw has a lot of pressure in it. Because this is an electric machine, when you apply voltage to a servo motor, it contains instantaneous torque. The torque is instant. So if you have a 30,000 psi of plastic pressure holding your screw tip, and it instantaneously rotate your screw, eventually the screw tip's going to snap. So what you do is you have a pressure release right here, and that's a decompression before rotate. That eliminates your screw from damaging, or your screw tip from breaking. If you watch this little curve, the factory kind of does this automatically anyways, but it takes more time. If you use the decompress or pressure release, it's going to be a lot quicker. So what happens, it's going to inject here, it'll go to hold, and then you just watch your screw. Your screw will actually rotate back until it hits this cutoff position. Then it'll start rotating. So it kind of forces the screw back before it hits that cutoff line. So you're actually wasting time because you're waiting for the screw to get back. So it's always best to just put the pressure release on. That way you don't have to worry about waiting for the cycle. It probably saves you 0.2 of a second just in turning that on. Again, this is your charge position, velocity, back pressure. Again, it's not actual back pressure. The way they achieve back pressure on these machines is they have you have your charge motor and you have your injection motor. So they put a voltage on the injection motor to kind of hold it from going backwards. So that's how they achieve back pressure on these machines. Again, this is your suck back. If you turn intrusion on, you're going to have settings over here for intrusion, and you're going to have an intrusion time. So you have your RPMs for intrusion, your pressure for intrusion, and your not back pressure, I'm sorry, just your velocity and your pressure. And you'll have a time that'll show up down over here for intrusion. Again, HPM, I never use that. Intrusion. Does everybody, if nobody knows what intrusion is, what it is if you have like a 4-ounce barrel and you have a 5-ounce part, what you can do is turn intrusion on for a certain amount of time. Before the machine goes to inject, it'll rotate the screw for the amount of time that you put in the intrusion time. When it's done timing out, it'll then inject the plastic into the mold. So you can actually fill the mold, pre-fill the mold, then inject, and then you can, it allows you to have a bigger shot size than your machine's capability. Mold open during charge. Of course, you only want to use that if you have a shutoff nozzle on. Again, with also clamping during charge. Injection unit forward during charge. Injection unit backwards. Injection unit forward during injection, I'm sorry. Injection pressure sensor reference. That's to calibrate injection pressures, actually. Stop for maximum injection pressure alarm. So if your injection pressure goes above the alarm, it'll stop. No holding by abnormal switchover mode. That means if it finds that the cutoff was odd, it's not going to go into hold. Then you have your different injection ramps. You can have standard, LL, FF, etc. Nozzle digital output control mode. You can have it control your shutoff nozzle or whatever you want it to shut off, to control. Charge overtime. You tell the machine what you want it to do after the charge overtimes. You can stop at the end of the cycle. You can stop immediately. Different options. All right. Any questions on the injection section? All right, product. You have a quality flap. So the quality flap allows you, if you have a reject or whatever, to actually send a signal out. It tells you what to do. If you have a reject, you can start the ejectors. You can just keep them on the mold itself without ejecting the parts. If you have rejected pieces, you can send an output to a conveyor or whatever to actually make the conveyor go in the opposite direction so the bad parts won't mix in with the good parts. You have product counters, so you can set up this and do your box management, etc. So down here, if you turn the box manager on, parts quantity per part, per box, alarm timer for the box is filled. Then you can have your monitor alarm for your product, stop when the box is filled. If you have consecutive rejects, you tell it how many rejects you want it to allow, and what you want it to do if you have a reject, either reject or don't eject or whatever. This is your quality page where you set your base value. Once the machine's running, just hit this base value here. You put your plus or minus offsets in, and if there's a deviation from that plus or minus offset, then it'll go into an alarm. It'll count it as a reject, and it'll do whatever you tell the machine to do with the reject. You can have the robot remove the reject or put it in a different area. You can have the conveyor go the opposite way. You can have a diverter shoot divert it. There's a lot of different options. It's basically just a signal that's going out to whatever device you want it to control. Again, if you have a camera, you can actually use the external reject input signal. And that'll also count the part as a reject in your box management system. This is your statistics. It's 20 lines. It'll just keep track of the first 20, and it'll keep scrolling down. And then you have your min, max, average, and deviation. You can save this to a CF card if you want. For people that want to save all the cycle times, you can actually save all the cycle times to a CF card. And if you don't want to do every single cycle, let's say you only want to check every 10 cycles, you just change the interval time. Data records, this is, I believe, it goes up to 200 pages, 25 lines per page. So this again is a record of all the processes it's running. Notice you cannot have there's no clear signal, so you can't clear this page. It just keeps scrolling on and on and on. Mold, this is where you save your setups. Again, it's always advisable to have a drive E, which is a USB drive, and save both C and E. That way, if you ever lose your CF card on your machine, then you'll have a backup of all your settings. You can actually go and highlight one of the setups. Say this was a setup here, highlight it, hit copy, go to drive E, hit paste, and it'll paste it into that drive E. So then you'll have a backup of that setup. You can also do it by saving using the save button. Blue just set up, go to drive E, hit the save button, it's going to save it to drive E also. Optional functions, that would be where you have your programmable inputs and your programmable outputs. They would be in the optional function page. Optional modules, if you have any other modules besides the standard, they would show up here. This one has a CIO 021, which is a programmable IO module. So the first section, first 8 would be your inputs, the second 8 would be your outputs. This is the status of the drives. So if you ever change a Diaz module, again, this is the addressing for your Diaz module. The Diaz module is a little module that fits on the front of your drive. Some of them are, the older style has the addressing. The newer style doesn't have any addressing. These are your analogs for your temperature. and your injection pressure, ejector scale, and your carriage scale, and your hydraulic pressure and flows. If you ever see a symbol like this, that means you can force the signal high or you can force the signal low. Highly recommend not doing it with the with the dries enabled or the heaters enabled, but you can test your circuits if you want to. Let's say you had a problem with zone 1. By forcing it high, you can then check the circuit without actually having power going to it, except for the 24-volt end. So you would shut off the heats, force the signal, check it, see if it's getting this 24 volts to the SSRs. Then you can force it off after, turn your heats on, and off you go. You can do the same with all of the outputs also. So every output on here, you can also force the outputs. You can check your signals at all your solenoids, etc. To make sure that the signal is going to the, for example, your core circuit. You can force those on and off to make sure that the cores are, the signals are proper, without even having to turn the machine on. You can set a robot. You can check those signals. And again, you have flexible outputs. All the new machines come with outputs, so you can assign those flexible outputs to be, for example, programmable outputs, screw rotate, and a whole bunch of different outputs. So when the service guy goes to commission your machine, make sure he selects the option for this, because I do believe you need to have level 5 to turn it on. But once it's turned on, you can use it freely. It's going to be on card number X31, locations 35 and 36. The nice thing about these machines, what I really like, is they actually tell you the locations of all the components, where the wires are. So if you would look at the board, which we'll go through tomorrow, it'll have X21, and the first pin is motor on, the second one is motor off, the third one is mold adjust forward, the fourth one is mold adjust back. These are actual connectors on the CPU inputs and output modules. Again, like the Mars machine, when the machine boots up, these are the actual signals that they're using and referencing on the input-output map. They're actually using these actual locations and signals. So if the blueprint's not correct, you can always look at this output or input module screen. You can find out exactly where the signal should be. Again, they're all marked X11, X12, and the actual connectors. Overview, that's just the overview of the machine as it's running. It gives you a little bit of information like the software version, function code. If you ever need an update, they need this software version. It's important when you're doing requesting an update. And then you have our actual positions, mode close, mode suck back timers. All your times are down here. Your screw position and injection positions down here. Cycle, this is a breakdown of your cycle in time. You can either do a text or an icon. Alarms. They changed the alarms a little bit. They made them customizable. You can actually have the alarms do whatever you want. You don't necessarily need to have, for example, the red lamp can be a message, or you can have it do anything you want. So you can have your buzzer. Let's say you wanted your buzzer to go off every time there was a yellow lamp. So you select over here and you put message. So anytime there was an alarm or a message, then the buzzer will sound. You can make it go continuous, or you could put a time in there to make it go just for a certain amount of time. So you're not going to listen to the buzzer sound repeatedly. You can just say, oh, just ring for 60 seconds or 20 seconds or whatever, and it'll just ring for that amount of time. Turn off. This is your lights out operation. The new machines also have, the new version has a auto purge. So it'll have an auto purge feature. So if you turn this on and it sees one of these alarms right here, after this amount of time that you put in this box, it'll do what you tell it to do in these boxes right here. So if you select a motor off and heater off, then if it sees a temperature deviation, motor and heaters will shut off. If it sees a cycle time abnormal, then the motors and heaters will shut off there. If your part count is reached, again, it'll shut them both off. And abnormal stop during the auto cycle, again, it'll shut your heats and motor off. And again, if you select auto purge, it'll also auto purge the machine. This is a list of your servo alarms. This is a list of normal alarms. And down here we have your change log. They use a graphic user ID, GUID card to log in. I think they give like 2 or 3 of them per machine. They don't give you that many cards. A lot of customers just hang them on the machine themselves. But again, this gives you the actual function that you're changing, the old value, and the new value. And it's also very clear to read. It's not no hieroglyphic writing. It's pretty straightforward as to what's been changed. The time and date also is here. And again, the nice feature is there's no clear button. So the operator cannot clear this. The only level that's the clear button shows is level 5. So if this is in level 5, then you'd have a clear button there, and that's the only level that you can actually reset the change log. Again, we don't give customers level 5 only because it can cause damage to the machine, especially when you're going into the drive sections, which I don't have shown here, but they'd have different drive sections in here where if you hit the reset drive button by accident, you then have to take the machine apart to recalibrate the machine. So we do not give level 5 access to our customers because it's kind of dangerous. They now allow you to have 0 set under level 3. So what 0 set does is you turn this guy on right here, and once you turn this 0 status on, you have to be very careful because the axes are now free to move wherever they want. So for example, you want to calibrate the mold. So you turn this guy on, you push the mold close button, and if you don't stop at the right position, the mold's going to keep going, and chances are it'll either seize up or something will break in the ball screw. So you have to be very careful when you're adjusting these axes. The only one that's safe to do is the injection and the ejectors. So injection, you just bring your injection unit, you screw all the way forward, hit the 0 end button, and then turn the 0 status off. You have to make sure if you turn this on that you turn it back off, because it overrides all the settings if you keep it on. If you need help, again, you can call the service department and we can help you. If you need any calibrations done on that, we can give you a hand on that. You can have a printer settings. If you can find a PCL 4, 5, or 6 printer, what a PCL 4, 5, and 6 printer is, it's a photo printer. I did find one at one time, and it just made a photo 4x6 size picture, which isn't really useful for anything. I think just by printing out the screenshots, it's a little bit better to view. Again, all of these presentations are done with screenshots. And again, you have your parameter settings. You can change your language. You can go from metric to imperial. You can use metric length or imperial length, or you can also use volume for injection. You have your date and time, your RFID system. You can keep level 1 on instead of, if you turn that on, then every time you log in, it'll be on level 1. This doesn't do anything. This is not even functional. Again, you have your screensaver time, same level card access mode, logging in or logging out. So what that means is when you log in on the level 3, you have to log out on the level 3. Any questions on any of these?